All right, so just again, going back up, when you're dealing with the buoyant force, your actual weight of the object, which we've calculated before, is Fg equals m times g. Again, we just take our mass times our 9.8, we get 196 newtons. But when you place an object in fluid, that changes, because again, the fluid's going to buoyancy you up. All right, and so again, to look at your apparent weight, or your weight when you're in the fluid, we take the force of gravity and we subtract the Fb. All right, because your apparent weight's always going to be more down than it is up. Otherwise, you would float up into the sky. Now, again, the other formula we have one for apparent weight. And we also have this other one where we have rho F, which again is density of the fluid. So that's what that F is. It's all about the fluid. And then we also have rho O. And rho O is the density of the object. All right, so again, that's why you have to be able to find density. All right, so we're going to try a couple of examples. Now, again, at the end of this note, you'll notice that I have, well, density of common substances. So we're going to use that chart. All right, so there it is. Lots of stuff. We have solids, we have liquids, we have gases. And as you can see, that the most dense stuff are solids. The next densest stuff are liquids. And, of course, lastly comes gases. All right, so that's just the structure of our substances. All right, so example number 1 here. It says a piece of material weighs 308 newtons. All right, but only weighs 238 newtons when placed in oil. What is the buoyant force? All right, well, in this case, our actual weight, or as we call it, Fg, is equal to 308 newtons. Now, it says it only weighs 238 newtons in oil. That's what we call our apparent weight. It's apparent, but it isn't true. 238 newtons. And what we're looking for is that Fb, the force, the buoyant force. All right, so again, we had our formula where we have our apparent weight, don't have any short form for that, is equal to Fg minus Fb. All right, so if I substitute in my values, all right, we know the apparent weight this time out, 238 newtons. All right, our Fg is 308 minus our Fb. Okay, now moving things around. I'm going to move my 238 to one side, my negative Fb to the other. And again, when things change sides, they change signs. So I'm going to have positive Fb on the left now. On the right, I have my 308. And now the 238 is moving over. So again, it's going to switch signs. And so I can figure out my buoyant force. To help me out here is 308 minus 238. And I get exactly 70 newtons. All right, now we get to the next part. It says, what is the density of the material? All right, well, again, we have that other formula, all right, where it's saying rho F, the density of the fluid, times Fg is equal to rho O, the density of the object, times Fb. Now, what do we know? We do know our Fg. We just figured out our Fb. And it says, what is the density of the material? Okay, so that's the object we're looking for. And we need the density of the fluid. Well, this has been placed in oil. So I'm going to go to that chart that's at the end of my note here. All right, so let's see here. All right, and so I look up oil. Let's see, we only got one oil here. I'm going to have to, I guess it's hydraulic. It has a density of 800, all right, kilograms per cubic meter. All right, so I'm going to take that, go back to my question here. And so the density of my fluid, again, is 800. So I got it now. All right, so now I'm going to substitute in and solve for the density of the object. And this is how sometimes they could identify the object. Oh, that's actually what we're going to do in C. All right, so again, row F is 800. Our FG, well, that's 308. We have some big numbers here. Is equal to row 0, or our density of our object, times our buoyant force, which I already found out to be 70 newtons. All right, well, simplifying things here, I'm going to take 800 and times it by 308, and I end up with 400. So what's that? 246,400. All right, is equal to 70 times rho. All right, and then our last step here to find the density of the object is I'm going to divide both sides by 70. And so I take that great big number there, and I divide it by 70, and let's see here, 246, whoops, turn the calculator on, 246, 400, divided by 70, and we get, wow, right on, 3,520 is our density, and again, that is kilograms per cubic meter. All right, now it says, what is the material? All right, so this is where I'm going to go back to my chart of densities of common substance here. And I'm going to look for a value of 3,520. And let's see here, big numbers, so I'm going to look over in the solids. Right here, right on, 3,520. And what we have here is we've got ourselves a diamond. So, what is the material? It's expensive. Better get it out of that oil. It's a diamond. All right, let's try another one of those. Let's see here. What do we got this time? Ooh, a piece of gold has a mass of 10 kilograms. If it weighs 30 newtons in an unknown liquid, what is the buoyant force? Okay, so first off, what do we know? Well, we do know the mass, which is 10 kilograms. And because of that, we can actually find out the force of gravity. Because again, it's m times g, your 10 times your 9.8. Which, actually, I can figure that one out already here. It's going to be 98 newtons. Now, the other thing is it says it weighs 30 newtons in an unknown liquid. So that is going to be our apparent weight. It's apparently what it weighs. Again, we've got 30 newtons there. All right. And we want the buoyant force, FB. All right, so again, I'm going to use that formula that I had before, where our apparent weight is equal to Fg minus that FB. All right, so once again, I substitute in here. The apparent weight is only 30 newtons. All right, Fg is 98 newtons. And, of course, we go minus FB. All right, so I'm going to move things around here. I'm going to move that minus FB again over to the other side. Same thing with the 30, switching sides here. So that negative FB becomes a positive FB. And then we have that 98 sitting there. It didn't move. The 30 gets moved to the other side, so it becomes a negative 30. And, well, 98 minus 30, I'm going to end up with a buoyant force of 68 newtons. All right, then again, it comes down to the question, what is the density of the unknown liquid? All right, so again, using that formula we had where the density of the fluid times Fg is equal to the density of the object times Fb. All right, now we know Fg, we figured that out. We know FB, we just figured that out. We want the density of the fluid, so we got to make sure we're substituting in for the right row here. Row O, the density of the object. we can find that on our chart because I know that a piece of gold is being thrown in there. In fact, like a 25 pound piece of gold. Lucky person. All right, so again, I'm going to go to my chart, look up gold. It's got to be under solids, and there it is. It is under 19,300 right there is our density of gold. All right, so we'll go back. Let's plug that in. It is 19,300 if my memory serves me. Again. All right. So now I've got everything I need. I'm going to substitute everything back in here. So we don't know our, let's get some bigger letters here. We don't know the density of our fluid. The force of gravity is just 98 newtons. All right, the density of our object we know is 19,300. That was for gold. And our buoyant force here was 68 newtons. All right, just simplifying things. Rho times 98. Well, I go 98 times rho. Always put the number first. It's not wrong the other way, but it's just common practice. All right, now I take 19,300 times it by 68. And I get 400. Which is, let's see here. Ooh, we're getting in the millions here. 1,312,400. All right, and then to get that density by itself, I'm going to divide both sides here by 98. So those divide each other off. And the density of our object, we take that 1,312,400, and I'm going to divide it by 98. And I end up with 391.84 kilograms per cubic meter. And there we go. There's our density. And then it says, what is the density of the unknown liquid? Ooh, that's a big number. Huh. Okay, so again, I'm going to go to my chart, look for something 13,391. Density of my common subjects. All right, it says it's a liquid. Is that true? We're looking for, what was it, 13,391. And nothing's even close, so it must be mercury. Just might not be pure mercury. Might have a little bit of mix in there. But it looks like it's going to be mercury for us. Just most likely mercury I'll throw down. So let's put that in there. Most likely mercury. I don't think anything was even close. So it just had to be mercury with a little bit of something else mixed in there. And there we go. So again, that is dealing with the buoyant force. Again, when you have two objects, a liquid and most likely a solid, that are mixing together, that liquid will force the object upwards a little bit. Maybe not all the way, but there is some force on its way up.